Everyone, welcome to lesson 1 on successive differences in polynomials. We're now on objective 2. You're going to be able to write explicit polynomial expressions for sequences by investigating successive differences of those sequences. So in English, okay, in layman's terms for us, I don't understand any of that, but what I can tell you is that you're going to take a table of values and you're going to be able to create an equation based on those table values. That's all this is saying, okay? So let's go ahead and get started. So in example 1, it says find the second difference. Okay, find the second difference for a general quadratic equation. So I'm assuming that if you're watching this video that you've already learned successive differences or how to take that. So that's not what this video is about. We've already discussed that, and if you haven't seen it, check out the earlier video. So we're going to find the second difference. So we're going to go ahead and start. If you want the second difference, you got to take your first difference, okay? And we'll start at the bottom. So we're going to subtract these two. So I'm going to take 25a minus 16a, which is 9a, and then I'm going to take 5b and subtract 4b, which is just b, and the c's will cancel out, okay? So then I go another row up, boom, boom, and I say, okay, 16a minus 9a is 7a, and we're going to have plus b here because we're going to take 4b minus 3b, and c's will cancel. We go again, 9a minus 4a is 5a plus b. So hopefully you're seeing the pattern. If you do, you just keep going. Look, 5, 7, 9. So this one's going to be 3a plus b, and this last one is just going to be a plus b. Okay, that is the first difference. Now we're going to go ahead and take the differences again. We're going to get the second difference. The second difference, if it's constant, it's a quadratic or a degree 2 polynomial. So look, now we subtract these two. 9a minus 7 is 2a. The b's will cancel. 7a minus 5a is 2a. b minus b is 0. 5a minus 3a is 2a. And 3a minus a is 2a. The b's cancel. And notice that number is the same, 2a. So 2a is the second difference there. Okay, and this is going to be important in our next example, but that's huge. It's the same number all the way through on the second difference. 2a is a number, so that means it's a quadratic equation. So what do you notice about the second difference? Well, the constants, these are all the same. Okay, and so it's a quadratic equation and it's equal to 2a. Okay, so let's go ahead and move on and see how we're going to use that in the next two examples. So they've asked us in example 2, they're going to ask us to write a quadratic equation. Oops. So we know that the second difference has to be constant. So look at all these numbers here. We're going to get a number here. So let's start with our first difference. Okay, they want the quadratic equation, and that quadratic equation, we want it to be of the form ax squared plus bx plus c. That's what the form is, standard form. Okay, so let's go ahead and begin. So we're going to take 86 and we're going to subtract 57. Okay, and that's going to give us 29. So first difference is here. Now we're going to go 57 minus 34, which is 23. Okay, 34 minus 17 is 17. 17 minus 6 is 11. Okay, and 6 minus 1 is 5. Notice these numbers are all different. So this table is not a linear function. So let's look at second differences. Okay, so 29 minus 23 is 6. 23 minus 17 is 6. 17 minus 11 is 6. And 11 minus 5 is 6. So what that tells us, this number is constant, it's a quadratic. But from the last thing, we knew that in general, the second difference was equal to 2a. Do you remember that? So it is equal to 2a. So if we take 6 and divide that, so if we take our second difference, 6 is equal to 2a, and that 2a's from the previous example, divide each side by 2, guess what? We've got our a value, so a is equal to 3. Okay, so a is equal to 3. Now, we also know the c value, and because we have x being 0 here, we know the c value, because if we plug c in for this x and for this x, you're just left with c. So here's your c value. That's equal to c, and that happens when x equals 1. So we have a equals 3, we have c equals 1. Let's now go ahead and find our b value. Okay, so let's look what we have. We have y equals, our a value is 3, 3x squared plus bx plus 1. So now we just have to pick a point, and we're going to substitute in. Let's pick this point right here. So our y value is 6, so we have 6 is equal to 3 times our x value, which is 1, plus b times 1 plus 1. Remember, our x value here is 1. All right, so let's go ahead and simplify. We get 6 equals 1 squared times 3 is 3, 3 plus b plus 1. So 6 equals 4 plus b, so b equals 2. Okay, so now we have all three terms, and let's go ahead and write that equation. We're going to have y equals, our a value is 3, 3x squared. Our b value is 2x plus our y value, or c value, which was 1. There is the equation that represents that table. Okay, so let's go ahead and do one more example. And it's that same process. Write the quadratic equation. Okay, so ax squared plus bx plus c. And notice how we have our c value already. 5 is equal to c because this is our x value is 0 here. So let's start with our differences. So you have, now this is careful, negative 40 minus negative 23, right? So think about this, negative 40 minus negative 23, that's actually adding 23. So that difference there is going to be, make sure I get that right, it's negative 17. So negative 17. And then we're going to go negative 23 minus negative 10. So negative 23 minus negative 10 is negative 13. And then you'd go negative 10 minus negative 1, which is negative 9. And then negative 1 minus 4, which is negative 5. And then you would have 4 minus 5, which is negative 1. Now these are the first differences. Okay, I wrote all those out because they were negatives. That's how you do it, so hopefully that helps. If you take the second differences now, you are going to get, notice how if you go up, you're getting larger. So this is actually going to be, this would be negative 17 plus 13, that's negative 4, right? And then this one's negative 4, and negative 5 minus, that should be negative 1 there, sorry, negative 1. So negative 5 minus negative 1 is negative 5 plus 1, which is negative 4. So look, second differences now is the same number. It's a constant, so that's great. So what we do here now is we set negative 4 equal to 2a. So a equals negative 2, and remember we already have our c value. We only need our b value. So I'm going to use this point now, the first point I can use. And so I have y equals our a value negative 2x squared plus bx plus 5. And now substitute. Y is 4. Okay. Negative 2 times your x value squared plus b times your x value plus 5. And our x value in this case is 1. So 1, 1. Give us some more space here. and we have 4 equals negative 2 plus b plus 5. So you have 4 equals 3 plus b. Solving for b, by subtracting 3 from both sides, you get b equals 1. So now we can go ahead and write that equation as y equals negative 2x squared plus x plus 5. Okay, so that is how you write equations from a table of values. We stuck with quadratics here, but it works similarly with linear equations and cubics. If you have any questions or comments, type them below. We'll see you next time.